Thank you so much, Scott, and good morning, everyone. It really is really lovely to be here. I want to congratulate the organisers of the conference. I know it's been a big team effort, but if I can specifically thank James for his leadership in establishing this conference, it's really an amazing program with a great lineup of speakers, and a full credit to you for that. I wish I could attend more. Unfortunately, given that it's the run to the end of the year, I've been called twice to Canberra this week, so I'm in between 2 day trips to Canberra, but I'm really thrilled to be here with you this morning. So I'd also like to acknowledge the traditional owners of the land from which we're meeting, the Bronwyn people, and pay my respects to their elders past and present. I do want to acknowledge the incredible value that Indigenous Australians, our first scientists, bring to research and innovation, and in particular the need for us to keep working with Indigenous communities to embrace their knowledge and to walk together to a better future. So it's really great to be here, and it really has been fascinating to talk to people this morning and to really recognise that Australia is a global leader in quantum physics research, and that has been because of a significant investment that occurred maybe 20 years ago. But not only that, we are also a world leader in quantum ventures. And I was listening last night to the Quantum Tech podcast and just struck by how many Australian founders of companies are on that list, that podcast list. So we have a really well-deserved reputation for generating some fantastic Australian quantum talent. And some of the best and brightest minds working around the world are from Australia. I want to highlight that 20 years ago, Cathy Foley, who was the previous chief scientist at CSIRO and now Australia's chief scientist, and I know she spoke yesterday, headed the team that developed LandTem technology, which utilises quantum sensors to detect mineral deposits. The commercialisation of this technology led to the discovery of more than $6 billion in mineral resources. So quantum is not new to Australia and not new to CSIRO. And it's really something that we are good at, something that we have a long track record in, and something that we will continue to focus on in a number of ways. And you can see that this is an incredible time for quantum with this wonderful alignment of national focus and international effort. CSIRO's quantum technology industry roadmap predicts that by the year 2040, we are going to have a quantum industry in Australia that's worth up to $4 billion and create 16,000 new jobs. That's in the context of a global quantum industry that's going to be worth around $86 billion at that time. The National Quantum Strategy, Australia's first ever quantum strategy, says that quantum technologies are also poised to grow globally by 33% in just the next 5 years alone. The strategy also makes the crucial point that we are not in this race alone. There is a huge acceleration in geopolitical interest and the rapid scaling of investment in other parts of the world. It's an environment where we cannot afford to lose our globally recognised edge, and it's also going to be really important for us to collaborate internationally. The National Quantum Strategy recognises the importance of commercialisation opportunities, robust infrastructure, a skilled workforce, clear standards and community trust to the long-term success of quantum in Australia. And in that context, I wanted to focus on 3 things today. The first thing is CSIRO's renewed focus on how we do our science and how we think about how we invest in science, and that is around our challenge strategy. I'm going to talk about that. The second thing I'm going to talk about is our future science and technology plan. As I've had really interesting conversations with colleagues this morning, what we do now will matter in the next 20 years, and I'll talk about that later. And then finally, I want to talk about responsible innovation and the work that we're doing at CSIRO to make sure we have the guardrails around any new technology or innovation to support responsible innovation. But let me start by talking about how CSIRO's approach has changed over the last few years. In many ways, CSIRO's mandate is unique. We are Australia's national science agency, and we are here to create national and economic benefit and social benefit for all Australians and Australia more broadly. We are facing some really significant challenges, and increasingly we're called on to develop solutions to challenges that require systems thinking, they're often extremely complex and very urgent. And we give effect to our legislative mandate by embedding the requirement to assist Australia's governments, industries, communities, and most importantly, our education and research sectors into 6 challenges which guide our organisation strategy. So I'm going to talk briefly about these 6 challenges now. So the first challenge is health and wellbeing, where we are working to enhance the health of Australians through preventative, personalised, biomedical and digital health services. Our second challenge is around food security and quality, to achieve sustainable security through new agri-food products, new food innovation, technology and innovation. Thirdly, securing Australia in the region, where we are helping to build safeguards from threats like pandemics, biosecurity threats, natural disasters and cyber attacks. Fourthly, resilient and valuable environments by enhancing the resilient, sustainable use and value of our natural and built environments, including by mitigating and adapting to the impacts of climate and global change. The fifth challenge is sustainable energy and resources, building competitiveness, sustainability and security nationally and regionally of our energy and mineral systems and resources while lowering emissions to reach net zero. And finally, future industries, where we are helping to create Australia's future industries and jobs by collaborating to boost innovation performance and promote STEM skills, making sure we are inspiring and creating opportunities for that next generation of STEM leaders. The focus on future industries is something that I'm really passionate about, and it's aligned with my own background in advanced manufacturing and materials technologies. So CSIRO's 6 challenges were established by deep thinking and careful analysis of a number of different reports. They are aligned with the new national science and research priorities. They were informed by CSIRO's Megatrends report, which is always an interesting read when it's released every 4 years. And we looked at our own modelling and forecasting, as well as looking globally at international trends. Another key focus area for CSIRO is less about the immediate for today and more about tomorrow. So Australia launched its Future Science platforms in 2016, and since this time, we have established more than 20 of them. They are deliberate interventions into high-risk, high-impact science, which is designed to fail and fail fast if it fails, and if it succeeds, then we look at how we can integrate it into our business as usual. So they each have around about a 5-year lifespan, and you'll be familiar with our Quantum Technologies Future Science platform. We also have a Responsible Innovation Future Science platform. We have some significant work being done around our Revolutionary Energy Storage Systems Future Science platform, which is represented here by Adam today. And we are also, he did a significant amount of the thinking in design of that. We also have a Future Science platform on artificial intelligence and machine learning. So what's next? How do we understand what the next investments in Future Science platform should be? And one of the things that I learnt in the first year of joining CSIRO and attending a number of different launches of successful startups and new companies that were being spun out from CSIRO, I would look around the room and I'd always find a quiet scientist very humbly standing at the back of the room, and I'd sidle up to them and speak to them about when they started working on that particular technology. Inevitably, they'd tell me that they started working on it 20 years ago. So what we do now, the science we invest in now, will make a difference in 20 years. And the conversations I had this morning were really around Australia's healthy, vibrant quantum ecosystem and the decisions that were made 20 years ago that have led to the creation of this amazing opportunity we have in front of us today. So we're thinking about what matters for the future. It's been a year-long process. We've really ramped it up this year. We've harnessed the ideas of our scientists internally at CSIRO. We've engaged with CSIRO Futures, who have conducted a series of interviews globally with experts from around the world, understanding where they think the challenges are. And we have a synthesis workshop next week where we're bringing these ideas together. There are so many ideas for quantum technologies that have come out, and James is leading some work around quantum robotics. We also have ideas around quantum stack software, where we could help Australia lead the development of quantum stacks to control quantum computers. We are also doing a significant amount of work on quantum machine learning, and Mohammed Usman published a paper very recently that I had an industry partner inform me that they think is an absolute world first. So there's some really exciting things happening in this space, and we are continuing to develop these ideas. They're blue sky, they're high risk, they're deliberately high risk, and we're really excited about where they might lead. I wanted to talk a little bit about some reflections on how we make it real. And making it real is one of CSIRO's 4 values. To me, it's a really important value. How do we make it real, and what's CSIRO's role in all of this? And how do we ensure the maximum benefit for Australians and Australia? I've watched with particular interest, as we all have, how IBM has co-located its facilities in Germany with the Fraunhofer, one of Germany's national science agencies. The reason why they've done that is that it gives them access to industry verticals as they start to build use cases. Here in Australia, this could be part of CSIRO's role. It could be something that we could support. We can provide access to industry and help industry understand quantum and embrace the technology in the same way that the Fraunhofer is doing with the IBM in Germany. And I had the opportunity to visit the centre in Einingen in September 2022. That's actually my picture of the quantum computer there. Einingen is a tiny town about 30 minutes out of Stuttgart, and the railway station, when I entered the railway station, I thought I was completely lost. I felt like I was in Mount Waverley, and I eventually found the campus and found the contact there, and there is an incredible campus of IBM in Einingen with 3 new buildings being built to support the Fraunhofer. So the IBM really see that value in that partnership, as do the Fraunhofer. It really led me to reflect a little bit about Industry 4.0 and how that evolved in Germany. So the German government created the platform in the mid-2010s. And I got involved in Industry 4.0 in Germany in around 2016 and had the opportunity to visit a number of their national network of test labs. So test labs are physical facilities where you can go and experience the benefits of Industry 4.0. And they were really important in bringing industry along and showing the value of Industry 4.0, which, let's face it, it was a concept in the beginning. And these test labs had to help to make it real. One of the most memorable test labs that I had a chance to visit was a Siemens test lab that was focused on optimising and the energy in the electricity grid. So in Germany, they have negative energy pricing. And if there's a peak in solar or a peak in wind, that creates additional pressure on the grid. And it means that there's incentives to use more energy on that day. So if you're a manufacturing company, you can actually schedule your manufacturing times for peak solar, peak wind. You can make more money from manufacturing, as well as making money from reducing the pressure on the grid and using more electricity at that time. And they were using very sophisticated digital tools to do that. So James has subsequently told me that at NREL, one of the national labs in the United States, that there is a quantum computing centre where they have interfaced quantum computers with the power electric grid equipment. So there'll be some really interesting opportunities for not just new energy storage technologies and new energy concepts, but also around energy management systems and how we manage energy in a better way. So for us, the question at CSIRO is, how do you create those use cases where industry can see the benefit and talk about it, and they can actually talk about the value? Because that's how you build buy-in, that's how you build momentum, and that's how you build the industry pool for all of the science that you've been talking about this week and all of the opportunities that you've identified at this conference. And we think that there's a role for CSIRO because of our expertise and deep networks into all sorts of different sectors across Australia. So there are 2 points there. One of them is the centrality of the National Science Agency in facilitating engagement with industry, all industry, because we're working with everyone. And then there's also the access to deep partnerships and trust. So trust is really critical when you're building anything new. So the other key point is building out those use cases, making it real, constantly making it real, demonstrating the benefit. That was how I saw momentum build up around Industry 4.0 in Germany, and that's how I think we can accelerate the progress of quantum technologies in Australia. So I want to just finish finally by changing the focus and talking about responsible innovation and its importance. We know that quantum technologies will drive a wave of innovation and profound change. So I wanted to offer a broader perspective about why it's so important to build quantum capabilities and all technology-driven innovation on a strong foundation of ethical principles and strong governance structures, to build it within the guardrails of responsible innovation. Because what we do is important, but how we do it is also really important. CSIRO, through its Responsible Innovation Future Science platform, is at the leading edge of this important work, examining the world that sits between what we could do with the technology and what we should do. And I want to turn there now. The big idea behind our Responsible Innovation Future Science platform is that science and the application of scientific knowledge does not take place in isolation, in a sterile bubble. It's linked to and part of the social environment in which it operates. So society has a stake in what scientists do because it is directly impacted by its outcomes, particularly when used to inform evidence-based decision-making. So this leads us to a number of big questions. Questions like, how can we best design and deliver responsible, trusted and innovative science and technology in ways that improve the lives of all Australians? I want to finish with a conversation about what it might look like. And I know that you're all very familiar with Robert Oppenheimer, particularly after this year. But one thing that he said that I really resonated with me was the best way to send information is to wrap it up in a person. Picking up on that concept, I would say the best way to build innovation now and into the future is to wrap it up in people-focused ideas of fairness, values, diversity, inclusion and responsibility. So let me finish with one final thought. No community, no researcher, no research organisation, no matter its size, can work effectively in isolation. So we need to continue to collaborate with researchers across the ecosystem, with government agencies like CSIRO, universities, research institutes in Australia and overseas, with colleagues in state and federal governments and agencies, with members of the Australian community and industry. I look forward to working with you all as we come together boldly to articulate our vision for the quantum revolution and the wave of change that it will shape for the future of Australia. Thank you.
Thank you, Bronwyn. Any questions? Any questions from the audience?
Hi, thanks for the talk. Yeah, I was just wondering how academics, particularly who work in theory in the quantum space, can engage with CSIRO to help make connections with industry. Because I often find that industry, the notion of theory often means like maybe speculative or very far off in the future. And like recently, we've been using the word software to refer to activities on the theory side. And is there a good way that some academics in that space could engage with CSIRO to make those connections?
Well, first of all, it's great that you're here and you're networking with the people in this room, because they're the people who can help you do that. What I'm seeing is an investment from industry in quantum technologies that hasn't happened before. I had the opportunity to visit Merck in Germany just this year, and they now have a quantum team. So the quantum literacy in industry is increasing, which means that they're more open in sharing their challenges and throwing out ideas and saying, wouldn't it be amazing if we could do this? So I think those two coming together will really help, and we're delighted to help play a role, because often we're working with that industry and seeing the establishment of that quantum group in that particular company, and we can help you connect you to them, but also help being a little bit of the Babel fish as well, because it's often that they're speaking a different language.
Thanks, that was very, very interesting and inspiring. I just wanted to ask you if there was a process that you have for identifying the next Wi-Fi. So how do you can't fund everything, you can't support everything.
Correct.
Is there a deterministic process of seeing something being done today, equivalent of some joke of what on a chip, that in 20 years' time will be more basic and
So we have a framework by which we are having these discussions, and we use those to understand, is this disruptive or consolidating? Is this really risky? What's the risk level? What are the opportunities to make it happen? One of the things I'm really fascinated with was a paper in Nature from January this year, which looked at the level of disruptive science over time, and that it had decreased as a proportion of all of the science being done. So we're really pushing ourselves, and that paper established a metric to understand whether science was consolidating and working within a paradigm, or whether it was disruptive and throwing out a completely new paradigm. We're really using that as a bit of a framework for our thinking. And then the other thing that has really struck me is watching Michelle Simmons' Boyer lectures. And, one of the key things she said made a difference to her work was the scanning tunneling microscope. So, sometimes we kind of devalue the development of tools, but these tools can lead to entire new fields of research. So staying focused on some of the tools and instrumentations, what's the next scanning tunneling microscope, is something that's really important for us to think about in these considerations too.
Involved in quantum research really involves quite a lot of experimental infrastructure.
Well, we have some incredible facilities in Linfield that Scott can speak to more than I can. We absolutely have an appetite, but we have an appetite to partner and look at how we can invest with state governments, how we can invest with other partners to create national facilities that are of national benefit. We absolutely are focused on that. I was fortunate enough to partner with CSIRO to build a facility that was focused on 3D printing of materials, and I've seen that model work really well, and I know that there's an appetite to do more of that. We don't need to do everything alone. How do we make sure that we are creating the infrastructure that will really seed that next amazing experiment that's going to be a world breakthrough?